All right, sports fans, we went over a skill today in class that kind of adds on to what we did the other week, the other class period, actually. We were working on coming up with names for these ionic compounds, and we realized that naming the first, or using the first two naming rules are pretty simple. You name the metal, and you give the IDE ending to the nonmetal, but look at what happens on some of these like 12 and 13. We've got chromium and we have chlorine, but in two different formulas, and it looks like they're going to have the same name if you apply the first two rules. Remember, chromium is a variable charge ion, so it's a metal that doesn't always have the same charge. So I'm going to show you on the board how we come up with the name. First, I'm going to show you how it looks like they should have the same name, and then we'll teach you how to apply the last rule on our naming booklet. There's one down here that talks about using these Roman numerals when necessary. Okay, so let's take these both through the first couple naming rules for ionic compounds. They are on your naming booklet on the outside, okay? Outside. So rule number one is name the metal. Don't change the name from the periodic table whatsoever. So in both of these cases, it's chromium, okay? So the name should look like that, the first part of it, right? Chromium. Then the nonmetal in both cases is chlorine, and chlorine is a halogen. That's all the way over, almost, to this far side of the periodic table over here. Where is it? Boom, it's right there, okay? Chlorine is a halogen. It's got 7 valence electrons, and it wants to pick up one more extra valence electron. We change chlorine to chloride. And that's it. Both formulas, though, when you follow those two rules, you end up with the same name. And it's not the same name for both of those. So here's where we apply a Roman numeral. We need to describe chromium. Something is going on with chromium here. In this case, they have a bond with 2 chlorines. And in this case, it's bonded with 3 chlorine, right? And so here's how we figure it out. Look at the nonmetal. The key is the nonmetal, chlorine. Chlorine on the periodic table, like we just showed you, is all the way over here. It's one step away from becoming stable like argon is, one step away from being similar to a noble gas, which means when chlorine does get that 1 valence electron, it's going to have a charge of -1 on it. Okay? We have 2 chloride ions here. They're both identical. They both have a -1 charge, and they're bonded with 1 chromium. So the question then becomes, what does the charge on this 1 chromium ion have to be in order to distribute a valence electron here and a valence electron here when it bonds with those 2 chlorines? And the only acceptable answer is it had to give up 2 valence electrons. So this must be chromium plus 2. All right? This +2, this charge of +2 is what's represented in the actual name of this right here. This is chromium 2 chloride, and we would write that by putting the Roman numeral 2 in here. Sorry about squeezing it in, right by chromium. Okay, so what's going on over here? We have 3 chlorines instead of the 2 that we had over here, but each chloride ion looks exactly like this. So let's write 3 of them. If we have 1 chlorine, 2 chlorines, 3 chlorines, and I keep saying chlorine, but those are chloride ions. Each one is trying to gain 1 valence electron. That's what gives them this -1 charge. And we still only have 1 chromium ion to provide those valence electrons. So what's the charge on this chromium supposed to be after it gives up 3 valence electrons? It had to be +3 to begin with, because it donated 1, 2, 3 valence electrons. So the name of this formula over here has to represent the fact that the charge on chromium was a +3. So this is chromium 2 chloride, and this is chromium 3 chloride. All right? Please don't make the mistake, just because in this one example that this was the 2, and so we made the Roman numeral 2, and we made the 3 over here, or this one has a 3, so we made the Roman numeral 3. That doesn't always work out that way, okay? If you've got questions, send me an email.